Hello everyone, this is Mohammed Saqib, your chemistry teacher. Welcome to our channel where you can get mastery of your concept within few minutes. So without further ado, let's start. Today we are going to discuss about a very important and interesting topic of chemistry, that is electrolysis, electrochemistry. It's a very applied topic. We have seen so many examples in our surrounding which is related to electrochemistry. For example, we can make different chemicals, we can make different substances by using the science of electrolysis. For example, we can decompose sodium chloride into its components, sodium and chlorine. We can break down put lead bromide into its components, lead and bromine, potassium chloride into much valuable potassium and chlorine. So, what is electrolysis? Electrolysis is decomposition of ionic compounds by passing electricity. Most of the time, we decompose ionic compounds because they ionize into positive and negative ions. Um, we can also decompose water by adding some acid or salt in it. We will discuss all these examples in this video. So electrolysis is decomposition of compounds, mostly ionic compounds, into its components by passing electricity. Such substances which decompose into their components are known as electrolytes. Electrolytes are mostly in the form of liquid, either in molten form or aqueous solution form. How we perform electrolysis? Have a look at a simple cell. For electrolysis, we need a simple electrolytic cell in which there are two rods dipped. Most of the time, these rods are of graphite because graphite is, number one, good conductor of electricity. Number two, graphite is easily available, it is cheap, and also it is inert substance. It does not react with the electrolyte. So you can see two rods here and a molten substance in this beaker. This molten substance is electrolyte, and these two rods are connected by a wire and a battery between them, because we provide external source of energy, and that energy decomposes the particles, the ions, into their atoms. In this process, one rod which is a positively charged, this positively charged surface is called anode, and oxidation takes place at anode. Always oxidation takes place. Okay, oxidation means loss of electron. So whoever comes at anode, it will be losing electron, and the other surface, it is cathode. It is negatively charged surface, and negatively charged surface is cathode. Positive ions, they travel toward cathode, and over there they gain electron. They are reduced. So positive surface anode, oxidation takes place here, loss of electron takes place here, and number two, negative surface called cathode. Okay, and reduction takes place at cathode, and the solution which you have in the beaker, that is electrolyte, their ions are traveling. So two things which you must remember. Number one, electrons travel through the wires and ions travel through the solution, through the electrolyte. So again, we have three components here. Number one, anode. Number two, cathode. And number three, the electrolyte in which the change is taking place. Okay. So let's have an example. Electrolysis of molten lead bromide. So first of all, look at the ions which we will get from lead bromide. So number one, lead ions, and number two, bromide ions. Lead ions are positively charged, bromide ions are negatively charged. So positively charged ions, they move towards cathode, and negatively charged ions, bromide ions, they move towards anode. Okay. So at anode, oxidation takes place, mean loss of electron. So two bromide ions which move toward anode, they will lose two electron and they will convert into bromine gas, and two electrons travel through the wire and they come towards cathode. Over there, lead positively charged ions are moving toward cathode, and at cathode they will receive those two electrons and they will convert into lead metal. Have a look at the ionic half equation of this cell. At anode taking place, and at anode bromide ions are being oxidized and they are converting into bromine gas. So you can see brown gas coming out through anode, and lead is moving at cathode. Lead ion, they have positive 2 charge, they will gain 2 electrons, they will convert into lead metal, and you will see silvery surface of cathode there. Have a look at another example. This is electrolysis of molten sodium chloride. So in molten sodium chloride, there will be 2 types of ions. Number 1, sodium ions, and number 2, chloride ions. Sodium ions are positively charged, they will travel toward cathode. Chloride ions are negatively charged, they will move toward anode. Chloride ions will move to anode, and over there they will lose electron and they will convert into chlorine atom. 2 chlorine atom will join and they will form Cl2, because chlorine is always diatomic gas. So first will make one atom and then another atom, and they will join with each other. They will make a chlorine molecule gas. And on the other hand, at cathode, you can see cathode will receive sodium ions, positively charged ions at cathode, and they will receive the electron which are traveling from anode toward cathode through the wire. The electron which are lost by chloride ion, those electrons travel toward cathode, and over there those electrons are received by sodium, and sodium ion will convert into sodium metal. So at anode you will be receiving chlorine gas, a greenish gas coming out from anode, and a silvery shiny metal that is deposited at cathode. Okay, you can see ionic equation. You have to write what is happening at anode, what's happening at cathode, and then overall equation you also should write that sodium plus chloride ion, and they make sodium chloride. Okay, hope you got this. In our next video we will be talking about electrolysis of some aqueous solution. Okay, thank you.